for you, so it can give you timely feedback to make sure the lesson is effective. Okay, now let's start lesson. Okay, so I'll mute all of you first. So if there's any question you want to ask, please raise your hand. And Jonathan, can you always show me your face, put your face in front of the camera? Thank you. If not, I don't know whether you are attending or not. Thank you, okay? Show me your handsome face, okay? Thank you. Thank you, everyone. Okay, let's start now. Okay, so this lesson will be focusing on resistance, effective resistance. Okay, we have talked about the simple examples last week. So when we find the total resistance of resistors connected in series, this is the formula. We shall find the sum, okay, R1 plus R2 plus R3 plus until Rn. Okay. Oh, welcome back, Rachel. Okay, give you a trophy. Okay. Okay, then, okay, for connected in parallel, this is the formula. Okay, so this R is actually we call the effective resistance. Okay, any questions so far? Please let me know if you cannot hear me or you cannot see what I'm writing on the notes. You can raise your hand. Okay, okay, so we'll try to combine the 3 resistors into 1 resistor. Okay, this is the effective resistance of it. So there are some examples. Let's look at this example. What is the largest and the smallest possible resistance which can be obtained by connecting 6 ohm resistor and a 12 ohm resistor together? Okay, class, while you're attending the lesson, you can still write down notes on your physical copy. Okay, so earlier this class, I have sent you message. Okay, okay, for class in, it supports the function that we can actually upload your lesson notes before class. I'll upload all the notes to the chat, the class chat part. Then you can download. Please always download and print out before lesson start. And after the lesson, I'll assign you homework. Okay, so it will be under the part task. You know the interface when you first start class in, you can see chat and you can see task, right? Okay, any issue so far? Anyone don't know where to find it? This is only for our online lesson. And after the class, okay, you can actually watch the video. Okay, all the lesson will be recorded. You can watch the video. Watch the video of the lesson. Okay, so in case like certain parts you are still not very sure, you want to watch the video again, you can do so. Okay, this is actually for class in. Okay, this is all for class in. Okay, but if let's say you have questions from school, I have questions from school, okay, from schoolwork and all that, you want to ask me, you can still WhatsApp me. Okay, everything no change, just that we have a WhatsApp me. Okay, just that we have an additional platform to support your learning during this period that tuition has to be suspended, offline tuition has to be suspended due to the COVID-19 outbreak. All of you are Sec 4 students. I don't think we can wait for like until beginning of May to resume tuition. So class E is to give you a support. Okay, so if there's any technical issue, there's any question, just let me know. Okay, so let's say I cannot hear you, Ms. Chen. Please let me know. Okay, I cannot see clearly. Please let me know. Okay, just now you all did a very good job in learning how to use a small drawing board to upload your work. Okay. Okay, so let's look at this question. Let's come back to the lesson. Okay, so for the working, right, is you may want to consider either they are connected in series or they are connected in parallel. So if we have 6 ohm and 12 ohm connected in series, the resistance, effective resistance is 18 ohm. If we connected them in parallel, it's 4.0 ohm. Then you can say, oh, smallest total resistance, okay, smallest total resistance is 4.0 ohm. And the largest total resistance is 18 ohm. Okay, that's a concept. Okay, so the concept is actually the more resistance you connected in parallel, the smaller the effective resistance it is. Okay, please take note of that. The more resistor you connected in parallel, the smaller the effective resistance. Okay, so far? Okay. So now we look at the example, another example here. Okay. So if let's say we want to find the current, from the battery, we will do 20 ohm and 5 ohm, find the total resistance first. Then we can find the current equals to V divided by R, which is 3.0. Okay, so far okay? Can you understand? Now I want you to find, okay, class, I want you to find the current I1 and I2 respectively. Okay, please find I1 and I2 respectively. You may want to write down your working on the notes or on a piece of foolscap paper and upload to the drawing board. I'll give you the drawing board in 1 minute. So I have give you the drawing board. Do your working on a piece of paper and then take photo and upload. I want you to find I1 and I2 respectively. Okay, please write down your working. Oh, Jonathan, try to write down the working on the drawing board itself. Also can, if I mean this question is relatively okay, relatively easier. Okay, class, I'll suggest you to use paper to write because it's faster. Write on paper, then after that you take photo, it's faster. It's more straightforward. Okay. Too hot. Okay. I'll suggest you to write down everything on a piece of paper or on your notes. Okay. Then you upload, it's faster. You use the writing pad, it's very slow. Well done, Rachel. You got the correct answer. Rachel is the first one. But Rachel, your answer is like 90 degrees rotated. So for the next question onwards, please change the orientation of the phone photo. Thank you very much. Well done. Okay. Okay, I see Chloe is working. Very good, Chloe. Thank you. Well done. So Gareth and Jonathan, you can upload. It's a simple question lah. Okay, I don't think it's very hard. Okay, thank you, Jonathan. Very good. Well done. Well done, Jonathan. I like the way all of you presenting your work, all very neat and clear. Okay. Gareth, take a photo, please. Okay, thank you. Very good. Okay, everybody did a good job. Okay, so we'll move on. Okay, so we'll move on. Okay, so next part we'll talk about, okay, the graph here are all IV characteristics of the graph. Okay, so what does I represent? What does V represent? I'll get someone to answer the question. Very simple question, right? So, okay, I'll use this responder. What does IV represent? What is I? What is V? Symbol I represent what? Symbol V represent what? You should be able to see a responder. You can click it. Ah, nobody answer. Hey, hello class. What is I? What is I? What is V? We talk about it since last topic. Cannot. I need to try again. Restart. Do you see the responder? You try to catch a responder. Okay, Gareth. Gareth, please. What is I?
Current.
V?
Volt.
Yes, very good. Current and voltage. Okay, current and voltage. Thank you. Current and the voltage. My other classes feedback to me, class in is very fun because a lot of teaching tools for us to have interaction. Okay, thank you, Gareth. Okay, so let's look at another concept for metallic conductor, right? Do you remember so far we have learned one law related to metallic conductor? Who can still remember what's that law? That law is very, very important. We talk about resistance of metallic conductor. The resistance of metallic conductor, there's a particular law. Okay, who can remember it? You can click the responder. Think about it. Resistance of a metallic conductor. There's a property, there's a characteristic stated by one of the law. Oh, nobody. Okay, let me try again. Okay. Okay, there's a law talk about the characteristic of metallic conductor. Do you remember? We learned it as one of the fundamental laws. Okay, nobody. Okay, never mind. I use a slot machine. I'll pick someone to do it together. Okay. Okay, let's start now. Okay, Jonathan. Jonathan, do you remember what is Ohm's law? What does it state?
Yeah.
Yeah. What is Ohm's law about?
V equals IR.
Okay. V. Really? Are you sure? No. You
Is it?
no. Ohm's law tell you V and I are proportional.
Oh,
okay.
Yeah.
Okay. Directly, thank you. This talks about V and R are directly proportional, and when the physical conditions such as temperature is constant, and it actually is only for metallic conductor. Okay, only for metallic conductor. Class, please remember Ohm's law only applies for metallic conductor, not filament lamp, not thermistor, not diode. Okay, so we look at the diagram for filament lamp, for thermistor, and the diode now. So do you see as the voltage increases, the current increase less for filament lamp? Okay. So what happened to the resistance? What happened to the resistance? We know resistance is defined as V divided by I, right? So if V increase a lot, I increase a little bit, what happened to the R? Okay, so I give you two options. One is as I increases, R increase. The other one is B, R decrease. Please think about it. Okay, you can answer the question now. Think about for filament lamp, this particular resistor or conductor, as a current increases, what happened to the R? Does the R increase or decrease? Think about it. Gareth, good. Gareth answer already? Good. Okay. R equals to V divided by I. Okay. There's one part which is constant resistance. I think up to here is constant resistance. Then after that, you see the graph increase in this way. Thank you, Chloe, for your answer. Very good. John Gareth, very good, Chloe. Then, do you see as the current increase, voltage increase, the gradient of the graph decreases? So it actually shows increasing resistance due to higher temperature. So the answer should be A. Okay, so answer should be A. I'll end the answer here. Okay, so answer should be A. Okay, one more. Let me talk about it one more time. As a first part is a straight line, right? Same as the metallic conductor or metallic resistor. Okay, straight line, basically R is constant. Okay, resistance is the same. Okay, let's look at this statement. Note that the resistance of an IV graph is not the gradient, but the inverse of the gradient of the graph. Okay, take note of this. So for this graph, the gradient increases. Okay, current increases. Gradient decreases. Gradient decrease. So the inverse of gradient increase. You need to understand the graph. There will be questions on that. Then we talk about thermistor. Actually, we talked about thermistor already, but briefly. Thermistor actually is a conductor as if the therm tell you what, class? In physics, what does therm tell you? Anyone know the answer can raise your hand or click the responder. What does therm represent? Is it energy? Is it brightness? Is it temperature? Or is it volume? What does therm represent? One more time. We all learn the topic thermophysics. Still nobody. Okay, I use the slot machine then. Okay, Rachel, please. Rachel, you can just try to guess. For thermophysics, we talk about what? Temperature, or we talk about height, or we talk about distance for thermophysics?
Temperature.
Temperature, very good. Temperature. Okay, so basically, right, if you see therm, it basically is something related to heat and the temperature. Thank you, Rachel. Okay, you get a trophy. Thank you. Thank you. Okay, so for thermistor, the resistance will change when there's a change in temperature. The property is as temperature increase, the resistance will increase. Okay, take note of that for thermistor. Oh, sorry, the other way. Resistance will decrease. Okay, the resistance decreases as the temperature increases and the current increases. Okay, so we talk about diode. Diode, you need to understand, like for example, we have a current flow in this way. I'll draw the circuit. If I put an ammeter here, is there any current? Is there any current if I put the ammeter here? Okay, A is yes, B is no. Okay. Okay, is there any current? Start again. You may start now. For diode, we talk about diode in current electricity, the topic current electricity. So in this case, is there any current? If I connect like that, how does the current flow? Will there be any current? Class, you can start answering the question. Okay, good. Chloe, well done. Jonathan, well done. Gareth, well done. Rachel, please try. If you don't know, you can just guess. 50% of the chance can get it correct. It's either A or B. Okay. Let me go through. Okay, so basically the current will flow, there will be current. Okay, however, if I connect the diode in the other way, if I connect the diode in this way, okay, if I connect the diode in this way, okay, then there's the ammeter, there's no current, because the current only can flow in this direction. You can see there's a positive sign, right? It shows the current can only from the bigger side to the smaller one. So for diode, there's something called forward bias. That means the current can flow as per normal lah. There's current here, right? Current is very, very, very small. We'll see current is approximately equal to 0. And this region is called reverse biased. Reversed biased. Okay. Then if you increase the current further, diode is going to break down. That's how diode work. Okay. So we'll look at our notes. So I'll stop here for a while. We look at our worksheet we did last week. Okay, this is the worksheet we have last week. Okay. Which question did we stop at last week? Anyone still remember? Jonathan, do you remember which question we stopped at last week? Do you remember which question we stopped at? Is it question 15? Question 15, right? We finished question 14 already, did we? Have we finished question 14? This is a worksheet we did last week on DC circuit. On DC circuit. This is a worksheet on DC circuit. This is the worksheet on DC circuit. We stop at question 14, right? Yes. Yes, no?
I think so.
Yes.
I think so.
Okay, okay. Then we look at question 15. Okay, question 15. That's a circuit. Okay, let's look at question 15. This is the circuit. So in order to find the effective resistance of the circuit, we have to simplify the circuit first. So positive. Positive, negative, and then we can combine these two resistors into one single one, which is 6 ohm. Okay. What about when 6 ohm and 6 ohm connected in parallel? 6 ohm and 3 ohm connected in parallel. They are connected in parallel. Okay. Then we can say the resistance here equals to 1 over 6.0 plus 1 over 3.0. Okay. Then you can get R equals to 2.0 ohm. Okay. So we have a 2.0 ohm. Then after that, we have another one as 5.0 ohm. So what's the effective resistance? 5.0 plus 2.0, because they are connected in these two are connected in series. You can see the current flow like that. Flow through both. So it's 7.0 ohm. That's the total effective resistance of the circuit. Okay, if you want to copy down, you can copy down now. Okay, you can copy down now the working. Okay, let's move on to the next part. Okay, what about the EMF of the battery? Okay, EMF of the battery, we use which formula? Okay, I give you a few choices. Okay, for part A, is either we use epsilon to find as, this is symbol for EMF. We can use, okay, it is equals to maybe R times I. Option B, EMF equals to V times I. Option C, EMF equals to V divided by I. Option D, EMF equals to I squared times R. Okay. You can start answering the question now. We want to find EMF. What is the best formula for you to apply for part B? Please take note that the unit for EMF is what? Volt, right? So it's something like voltage, very similar to voltage. So the formula should be the first one. Should be the first one. Okay, should be the first one. Okay, thank you everyone. You all got the correct answer now. Okay, good. Okay, so we know the current floating out from the circuit is 0.70. So for your working, right, can you tell me, do you accept this EMF equals to V times EMF equals to I times R or R times I? Is it okay to do like that? What's wrong with this? Anyone know what's wrong with this? The proper working is EMF equals to 0.70 times 7.0, which is 4.9 volts. But can you just write 0.7 times 7? Anyone want to answer? Raise your hand, please. This is definitely not acceptable. Gareth, please. What's wrong with this working?
Must be 2SF.
Yes, 2SF. Very good. Thank you. Okay, thank you. Okay, so far okay. Can we move on? Okay, now let's look at question 16. Question 16, you are supposed to find the EMF of, the total resistance of the 3 resistor. So the R effective equals to, this is connected in series with the other two, right? So this, if you find the total resistance of these two is 1 over R equals to 1 over 6.0 plus 1 over 3.0. So the R equals to 2.0 ohm. Okay, so 1 ohm and 2 ohm connected in series. The total resistance is 1.00 plus, 1.0. I cannot add a 0 there. Okay, so it's 3.0 ohm. Okay, so what's the current? How do we find current? We'll use V equals to I times R, right? So the current equals to V divided by R, which is 6.0 divided by 3.0, which is 2.0 amperes. Okay, so then the current flow from the battery is 2.0. The current flow through the 1 ohm resistor is also 2.0. Okay, if there's any mistake you made just now, you can write down on your notes or on your worksheets. So far, okay? Any question? If you can understand this question, please raise your hand. Please raise your hand if you understand this question. Okay, good. Thank you. Okay, thank you. Okay, so we want to find, the next part is to find the potential difference across the 6 ohm resistor. Okay, this is less straightforward. This part D is actually less straightforward. Okay, so for part D, you need to understand we have 6 ohm, which is the sum of the voltage. I call this as V1 and another one as V2. Okay, this is actually the effective resistance of both 6.0 and the 3.0. So what is the voltage here? We can find V1 equals to 2.0 times 1.0, which is 2.0. Okay, so if here is 2.0, here will be 6.0 minus V2 equals to 6.0 minus 2.0, which is 4.0 volts. Okay, so far? Okay, so far? That's for part D. Then for part E, what is the current flowing through 3.0? So you can find, you already know the voltage, right? So we can use current equals to V divided by R, which is 4.0 divided by 3.0, which is 1.33 amperes. That's all. Okay. So I'll show you the I'll give you 30 seconds to look at the working, and then we'll talk about question 17. Question 17, if I'm not wrong, I remember it wasn't so well answered. Okay, I'll give you 30 seconds. Okay, I'll show you the working here. Okay, we'll move on to question 17 now. Let's move on to question 17. Okay, question 17, that's this part. Explain what is meant by the phrase an EMF equals to 9.0 volt. What is meant by? Please take note for all physics questions. Okay, for all physics questions, if they ask you what is meant by, they ask you for what? Ask you to explain, or ask you to like just write down whatever you understand, or it must be definition? Anyone know? Rachel? So if we see this question as what is meant by, we must write down is it the definition, or we can just anyhow write something we understand about the concept? Must be the definition. Very good. Thank you, Rachel. It must be the definition. Don't give me other things. Okay, class. How do we define EMF? How do we define EMF? EMF is defined as the work done by the source in driving a unit charge around the circuit. This is the defining equation of EMF. Please take note. Okay, please write down the definition. Okay, I think last week when I checked it, it wasn't very well answered. Okay, it means that 9.0 joule of work is done by the source. Okay, by the source in driving a unit charge around a complete circuit. Please write down the answer. Okay, this is the only way that we can answer the question. If it's a 1 mark question, if we talk about other things, sorry, no mark. Okay, must be strictly answer the question by using the definition. Okay, let me repeat. Explain what is meant by. Always ask you for the definition. Okay. Then we'll look at the second part on what is the effective resistance of when the switch is open. Okay, when the switch is open, it's actually just a normal complete circuit. Okay. So we can find what is this effective resistance. Okay. So what we can do is this part. This part we can use the formula. Class, you may want to take note of this formula. If you have 1 over R effective equals to 1 over R1 plus 1 over R2. We can also say effective resistance, right, equals to 1 over R1 plus 1 over R2 holding to the power of -1. It is easier for you to key into calculator. Okay, so you look at this, right? You can use calculator 1 over 2.0 plus 1 over 6.0 to the power of -1. For physics question, you just need to write down this part. Okay, you must show the substitution step. You must show this substitution step. Do not skip. Let me repeat. Okay, we now kind of simplify the formula to this. Take note. Effective resistance equals to 1 over R1 plus 1 over R2, then holding to the power of -1. You must show this substitution step. If not, you might not get the credits. Okay, you must show this substitution step. Okay, this is only for the part in connected in parallel. We cannot forget the 2.0. So the effective resistance of the, okay, maybe I call this effective 1. Effective total is 1.5 plus 3.0 equals to 4.5 ohm. That's working. Okay, take note of that. Okay, so when it's open, determine the reading on the ammeter, voltmeter when it's open. This part, anyone want me to go through? Please raise your hand. Don't be shy. Please let me know if you want me to go through. Anyone? If no, I'll continue. I'll continue the next part. Anyone want me to go through this part? If okay, then I'll continue. Okay, so then we talk about when switch is closed. Okay, when switch is closed. Okay, class, when switch is closed, become this, right? What are we going to say about these two resistors? What happened to them? There's a technical term, there's a physics term to describe what happened to the 6 ohm and the 6.0 ohm and the 2.0 ohm resistor. What happened to them? Is it closed circuit or open circuit? Gareth, what do you think? 6 point
Short circuit.
Short circuit, very good. Short circuit. The term is short circuit, very good. Thank you. Okay, thank you, Gareth. Okay, it's called short circuit. There's a short circuit because the current is so smart that current will flow through in this way. Okay, current will flow through in this way. Okay, there's no current here, no current here. Okay, so then you can think about what is the effective resistance of the circuit. Only 3.0, right? Only 3.0 ohm. Only this particular part is connected. Okay, only this particular part is connected. So what is the voltage? Oh, voltage should be 9.0 volts because the entire EMF will be the voltage across the 3.0 resistor. And then for current equals to V divided by R, which is 9.0 divided by 3.0, which is 3.0 ampere. Okay, that's all. That's a current. So you can answer the question in this way. Okay. You may want to do calculation as well. Okay, you may want to copy down the working. Okay, you may want to copy down the working. Okay, so now let's look at question 18. Have you finished copying? If you have done, then please raise your hand. Please raise your hand if you have done. Okay, thank you. Okay, thank you. Thank you, Rachel. Okay, thank you. Okay, now let's look at question 18. Okay. Question 18. First of all, you need to know the property of thermistor and the LDR. Okay. Question 18. Do you see the light source is placed close proximity to the LDR and the thermistor is heated? So when there's a this is the thermistor. When the temperature increases, just now we talk about it, the resistance will decrease. So for LDR, light dependent resistor, as it's brighter, okay, what happened to the R? Does the R increase or decrease? I'll give you option A, option B. Okay, option A, R increase. Option B, R decrease for LDR. You can start now. Oh, okay, everybody got the correct answer. Very good. Okay, well done. Yay, we can then continue to talk about the effect now. So basically the resistance in the circuit, the other two, right, both decrease in value. Then what happened to the overall resistance? What happened to the overall resistance? Okay, so the LDR decrease its resistance. You must explain these two clearly. Okay, then the overall resistance decreases as well, leading to an increase in the current. Okay, so you can talk about the power. Okay, remember we talk about the brightness of the light. I hope you still remember when we talk about brightness of the light bulb or lamp. Are we looking at I only or R only or voltage only or power? Okay, this is the next question. Please answer the MCQ question. When we talk about the brightness, okay, class, when we talk about the brightness of a light bulb, which one do we look at? Do we look at current? Do we look at resistance only? Or do we look at voltage only? Or we look at the overall power? It's an important question. Don't be affected by the question 18. Don't be affected by the question 18. So far, I see the correct answer from Chloe. Well done, Chloe. Okay, the rest of you will have to discuss together. Okay, we actually look at it as the power. Okay, that's what happened. But just the power equals to current square times r, I square r, or v square over r, right? So the r normally doesn't change, will remain constant. The resistance of light bulb is like something like an inherent property of it. It doesn't change, right? Since it doesn't change, you can use power directly proportional to I square or power directly proportional to V square to calculate. But you can say like the current increase, right? Brightness also increase. It is correct, but I think you shall link it to the power. So for this MCQ question, the best answer is D. Okay, the best answer is D. Please take note of that. Okay, please take note of that. Okay, so I give you some time to copy down. Okay, have you done? Have you done? Okay, have you done? Have you finished copying? Yes, please raise your hand if you have done already to confirm. Thank you. Jonathan, have you done? Okay, thank you. Okay, let's move on to next question. Okay, so the next part, right? Determine the resistance of the thermistor. I think it's not difficult, just that you need to make sure you read to half of the smallest division. I prefer to see 8.0 ohm rather than just 8. And what about the potential difference across the thermistor and LDR? How do we calculate that? How do we calculate that? Maybe Jonathan can share with us. Do you get the answer? Do you get the answer or no?
I haven't gotten it yet.
Haven't got it yet. Okay,
I
fine.
think I got.
Okay.
Yeah.
Okay. Rachel, have you gotten the answer? No. I think maybe I help you a bit. So class, you read this instruction here. Okay, voltage across is 2.0, right? Here is 2.0. This is 2.0. Total EMF is 12. Then what about the total potential difference across these two? Total is 12. Here is 2. What about the total EMF across it? Okay, class. You look at the graph here, the diagram here. 12, 2. What about the total here? You may want to use 12 minus 2. Okay, you may want to use 12.0 minus 2.0 to get 10.0 volts. Okay, that's the working for part C. Part B, part C. Okay, now let's look at the potential difference across L, D, R on V. Okay, we'll look at the next part. What is the potential difference across LDR? Do you need some time to do it or not really? Do you need some time to do it, class? Chloe, do you need a bit? Do you need some time to do it? No, you have done already, right?
No. No.
Okay. Okay. So we'll do this together. So basically, we are given the information. One is 42 ohm. The other one is 8 ohm. And the total potential difference across is 10, right? How can we find the potential difference across LDR? So you can say current equals to 10 divided by 42 plus 8, which is 0.20 amperes. And the voltage equals to I times R, which is 0.20 multiplied by 42, which is 8.4 volts. Okay, then what about the total effective resistance? Oh, sorry, this part. Then what about this 10? How do we find that? The circuit showing you that the voltage across the lamp is 2.0 volts, right? So the resistance of it equals to V divided by I, which is 2.0 divided by 0.20, which is 10 ohm. Okay, so the effective resistance equals to 50 plus 10, which is 60 ohm. Okay, so far? Can? Okay, let me know if you are ready for me to move on. We'll spend more time on the is it called assignment questions in the subsequent session. It's harder. Okay, so far, class? If you're okay, you raise your hand, please. Thank you. Okay. Okay, let's move on. Okay. Wow, this is pretty complicated. Just a check. Any one of you got the correct answer for A1? The answer is 6.0 amperes. I think the answer is printed in your student copy as well. 6.0 amperes, 4.0 amperes, 2.0 amperes, and 2.0 ohm. Any one of you got the correct answer? Jonathan, do you get the correct answer?
I haven't gotten I2 and 3 yet.
Okay. How about Gareth? Like, what are the answers you can get?
I haven't started.
Haven't started. Okay. Then how about Rachel? Do you get the correct answer?
All wrong.
Or okay. Okay, thank you. Okay, thank you for trying. Okay, anyway. Chloe, do you get all the answers?
I think so.
Oh, you okay, right? So okay, Chloe, you can maybe share with us how do you get I1? What's your approach? Maybe you can tell us what's your approach.
10 minus 4.
10 minus 4. Okay, we talk about it later. I think we have to simplify the circuit first. So class, I'll simplify the circuit. Okay, and there's a 10 ampere current flow into the circuit at first. So you remember just now Chloe said she used 10 minus 4. How does she get 4? I'll mute Chloe first. So Chloe, can you share with us where did you get the 4?
It's written in the question.
Okay, good. Do you see there's a 4 here? So the current actually split. After the current split, right, this branch, the I1 equals to 10 minus 4, which is 6 ampere. Thank you. Okay, so if you redraw the circuit, it looks like that. This is the circuit after you redraw. Okay, so 10 minus 4. Okay, that's for the I1. I1 equals to 10 minus 4, which equals to 6 amperes. Okay, so Chloe, maybe you can share with us how do you get part 2? I2, how do you find I2?
I found I3 first.
You find I3
Right.
first. Okay, find I3.
Yeah.
How do you find I3?
8 divided by 4.
Okay, good. So basically the voltage 8 is across X and Z. X and Z. Okay, so what she do is use 8 divided by 2.0 plus 2.0, which is 2.0 amperes. So the current here is 2.0 amperes. Okay. And how do you get I3?
Just now that one is
Oh,
I3.
sorry, that's not I3, it's I3. Yeah, correct. It's I3. This is I3. Then what about I2? What about I2? How do you get I2?
4.
4
6 minus 2.
divided by 6 minus 2. Okay, good.
No. It's just 6 minus 2.
Oh, just 6 minus 2. Okay. Six. Okay. Chloe, why do you use 6 minus 2? 6 is the current here, right? Because for parallel circuit, the current split, right? So this is 2.0. The below part is 4.0 amperes. Okay. Then Chloe, share with us how do you get the R?
8 divided by 4.
Very good, thank you. 8 divided by 4. Voltage divided by current. Okay, so this is a working. Okay, Chloe, you can continue with A3. I remember homework is until A2. Okay, now we can discuss about question 1. I'll mute all of you. So any question? I don't think A1 is a very easy question. So is there any question from you? Gareth, any part you want me to go through with you again? Can understand? Okay. Jonathan, okay, can understand? Or
Yep.
just tell me which part you need help with. Rachel, you can understand now. Okay, great. Okay, now we'll talk about, I think A2 is easier than A1. Okay, so I'll give you some time to try A2. I think some of you haven't done yet. Okay, for Chloe can continue question 3 onwards. Okay, for question 2, right? I'll hand out the blackboard and I want you to take a photo of your working and send to me. Okay, I'll hand out the blackboard now. After finish question 2, please take a photo and upload, so I can make sure everybody know how to do, or everybody knows how to present properly. Okay, you can actually delete or remove just now the photo. Okay, just now the photo you take for, I'll help you to delete. I'll help you to delete just now the photo. So everybody please upload your photo once you have done. Okay, take a photo. I have already helped you to clear all the small drawing board. After finish question A2, please take a photo of your working and upload. Okay, once you have done question 2, take photo. Okay, Chloe, I saw your working. Let me try yours. Class, please upload your working after you have done so I can mark for you. Chloe, do you see my marking there? Part A, Part B, very well done. Part C, the A2, right? You cannot use 12 because 12 is not the 12 is too much to be the potential difference across. Okay, you can see this part because there's 1, 2. These two parts together add up. The potential difference is 12, not only one part. Okay, class, I'll give you 1 more minute to upload your work. It's okay if you didn't finish completely. I'll show you the working later, but now I want you to at least show me the parts you have done. Then for part D, I think it's because part C is wrong, so Chloe may want to try the rest of the parts again. Okay, Rachel, I'm marking yours now. Rachel, same problem. The 12, right, is Rachel, for the 12 is not the voltage across the whole thing. So if you look at, you find this as a 2.0. The one you find is actually here. I can label here. The 2.0 you find is the total current before it's split into A2 and the other current. Okay, so this is not the final answer. Okay, this is not the final answer. Okay, class, please upload your working now. At least I can check for you. Okay, I can check for you. Please upload your working. Sorry, I need to go toilet. I'll be back in 1 minute time. Okay, how is it? Let me check you're working. Jonathan, just upload your working for whatever you have done so far. Okay. Gareth, I'm marking yours now. Good. Gareth did a good job. Very good, Gareth. Excellent. Your work is excellent. Jonathan, can you please upload your work for whatever you have done so far? You just upload so I can see your progress. It's okay if you haven't finished question 2 yet. Okay, later I'll show all of you Gareth's working. His working is very good, excellent. Jonathan, can you upload first?
Wait, I can't upload. Wait.
What's the problem? Okay, thank you. Okay, good. Part C, what's your answer, Jonathan?
1.5.
Okay, can. Okay, thank you. Okay, so class, I'll collect back the small drawing board. I'm going to show you Gareth's work. Very good. Gareth did a good job. Can all of you see his work? Can all of you see his work? So part A, part B. I think the problem starts from part C. Okay. Part C is a reading of A2. So first of all, he find the voltage first. After that, he can find the current. So the voltage across 2.0 and the 6.0 ohm resistor is 3.0 volts. Then 3.0 volts divided by 2 will be the current going through the individual branch, which is 2 ohm. So the final answer is 1.5 ampere. Very good, okay? Then for the part B, the reading of the voltmeter, we already find the current in the 2.0 ohm resistor is 1.5. Then you find the current in this branch. So that's the total current. So this part, I cannot write anymore. Okay, you can just see the highlighter part. This is total laser pointer, the laser pointer. So this is the total current flowing to the 4.5 ohm resistor. Then times the resistance, that gives you the voltage. Okay, very clear approach. And then for the next part, he found the reading of the ammeter A1. A1 is in the main branch, right? So he his approach is to find the total resistance of the circuit and then use 12, which is the EMF, divided by the total resistance. Then the final reading for it is 4.0 ampere. Okay, so it's very clear. Okay, so for the last part, if the wire of a negligible resistance is connected between X and Y, there will be a short circuit part, the A2, no more reading. As we always mention, current is so smart that it passes through the branch where there's no resistance. So there's no current pass through A2, so it's 0. Okay, so for the next part, A1, the reading of A1, just straight away find the total resistance of the circuit, and then after that, find the current in the branch. Current flowing through A1. Okay, very clear. Okay, very good, parents. Okay, so class, after doing question 2, okay, after you make changes in your working, you can continue with question 3. And meanwhile, please let me know if you have any question. Jonathan, can you understand?
Yeah.
Okay. Rachel, can you understand? Okay. Chloe, can you understand? Any questions so far? Okay, thank you. Thank you for your effort. Class, I hope you can learn the way that how the working shall be presented from Gareth's work. His working is very clear with the correct unit, with the substitution step and final answer, which is very good. Okay, you can after that do question 3, A3. Okay, I'll hand out the small writing board. So if you have done, take photo. And I'll help you to delete the working as well. Oh, okay, great. Chloe has done the question. Very good, Chloe. The rest of you, once you have done, you can upload. Great. Gareth also have done. Jonathan, well done. Rachel, well done. Okay, so I think question A3, I don't need to go through. All of you did a very good job. Okay, please continue with question 4. Please continue with question 4. Question 3, you all did very good. Okay, you did a good job. Okay, question 4, once you have done, please upload your working. Okay, I'll help you to delete the working for question 3. Sorry, I'll collect the small drawing board first. And the class, can I show you Chloe's working for question 3? Can you see? Do you notice she actually included the switch, which is good. Okay, all of you get the correct combination. Hi everyone, I need your attention. Hi everyone, please look at the small drawing board. All of you did good job to find the correct combination. Chloe, I think, is it Jonathan and Chloe? Both of them actually also include the switch. So please always include the switch to make the circuit perfect. Okay, please always include the switch. Okay, Thank you. Okay, now I give you the small drawing board again. So once you have done your work, you can upload. Okay, please explain to your parents that you use handphone to scan the QR code to upload your working, so I can give you timely feedback. It's not that we use handphone in class. Okay, please explain to your parents that. I think some parents have some concern. Why are you sure you ask my child to, play handphone in tuition class?
It's yours.
Gareth, very well done for question 4. Okay, Chloe, your A2, right, might not be very good. You shall show I2. Because when we find the current, we use the symbol I. Okay, Chloe. Your numerical answer is perfectly okay. Just that I prefer to see I2. And another thing, Chloe, look at the board. Do you notice you use 0.5? Can you use 0.50 to make sure it is 2 SF? Okay? Then here you can just say about P potential difference of PD or PD like that. Okay, good. You can upload the other photo. Well done. Okay. Chloe, your part on the voltage, right? 7.5 is not the total voltage across the R, because you see here they say the potential difference between A and B, so is R and here together is 7.5. So the 7.5 is incorrect. Please check again. Try again. Can you understand, Chloe? Okay. Rachel has avoided her work. Rachel, your part C seems incorrect. Rachel, please check your part C. If you are supposed to find the potential difference between A and B, you may want to find the total resistance. Rachel, you may want to find the total resistance. The total resistance part looks weird.
I cannot hear.
Can you hear me? You cannot hear me.
Very soft.
Oh, okay. Rachel, can you hear me now?
Yeah.
Okay. Part C is incorrect. You may want to check your total resistance. Your method kind of okay, but the value not correct for the resistance. Please double check. Thank you. Jonathan, have you uploaded your can you take a photo? Jonathan, have you done?
Couldn't do part C.
Couldn't do part C. Okay. Maybe you upload the part A, part B first. After that, okay, class. I think the common difficulty is you cannot do part C. I will Garrett's work in a short while. Okay, I can see you're working. Jonathan, so your part A is 0.50, is it?
Yeah.
I don't think that's correct. So the current 0.50 is the total current. You can see what I'm writing now, right, Jonathan? So do you see the current split? Like the ammeter is here. This is 0.50 ampere. Right? So the current here should be different. Like I1 times 5 equals to I2. I call the second branch as I2. First branch as I1 equals to I2 times 10. Because they are connected in parallel, they have the same voltage. So I1, which is 0.50 times 5 equals to I2 times 10. So I2 will be of a different value. Not 0.50. Shouldn't be have the same. Basically, the two branches shouldn't be have the same current. If you have your current as 0.50, it's not correct. Okay, class, I'll show you the work. I'll collect back the small writing board and I'm going to show you the working from Gareth. Okay, please take a note. You can look at here now. Okay, this is his working. Actually, for part C and the part D, he do the part D first. He finished the part D, which is the total resistance of the circuit first. Then he goes to find the EMF of the battery. Okay. So his method is, can still write, is R times he find the total resistance first. After that, he use total resistance, which is 10 ohm for the whole circuit times the current. Working. can take a look of Gareth's work. His work is very simple and straightforward. This is his PC. For the question 5, I want you to show me how do you simplify the. For question 5, right? Please show the simplified circuit. Draw the simplified circuit as well. Okay, class, have you seen Gareth's work? Can I remove it so I can give you the board for the next question? Next question is very important for you to show how do you simplify. How do you simplify? Okay, I'll hand out the board again. So I'll help you to delete all the working. So please try question 5 now. By the way, please use pencil and use pencil to draw the circuit diagram. Don't use pen. If you use pen, you are penalizing yourself in terms of time management. Okay, Chloe has uploaded her work. Thank you, Chloe. Chloe, are you sure this is the answer? Your opinion? I don't think it's correct. Not correct for part A. Let me see your diagram first. Just a second. Chloe, actually, actually your circuit diagram not really correct. Like it's one branch, two branch, they are connected in parallel. Then after that connected to this. So should be 15, 5, 20 ohm. Then with another 10 ohm. Then connected with another 60 ohm. Should be something like that. Okay, Chloe, please try this approach. Any question, Chloe? Can you understand the drawing? Okay, so basically, right, you can see 15 and the 5, they are connected in series first, right? Then connected in parallel with the 20 ohm. 15 and the 5 ohm connected in parallel with 20. Then they join here, they go through another 10 ohm resistor, right? Another 10 ohm resistor, right? So there's a 10 ohm here. After that, they will combine the current with the flowing from the 60 ohm resistor. So the circuits look like that. So we look at how does the current flow. Current flow one branch like this, right? One branch and this branch. So these two combine at this point B, flow back. Then this current flow through this point, combine, come back. Okay, so the current flow, then they combine. This one is connected. Okay, can I understand already? Okay, thank you. Okay, so we can try again. Okay, Gareth. Okay, Gareth, good. Effective resistance, well done. And part B. I want to see 2SF. Okay. Okay, good. Gareth, okay, good. Okay, so we are going to do a very okay. I can show you the working now. Let me see. Okay, good, Jonathan. First part, very well done. class, I'll collect back first. I want to show you Gareth's working. Okay, thank you, Gareth. You did a very good job today. Okay, so this is the working. So you can see the simplified circuit. Okay, so we look at the simplified circuit. What happened is the current at the point A, right, will split. So 15 and the 5, they are connected in series. These two are connected in series. Then the 20 will connect in parallel with them. And at the junction B, right, they join together. So you can see for his drawing circuit, the circuit diagram drawn by him. Then after that is this 10 ohm resistor. Then at this junction, all of them combine together. So this is a simplified circuit diagram. Okay. So first of all, the current flow through the two paths. So they're actually parallel. After this junction, they join back. Okay, and passing through the 10 ohm resistor. So there's a 10 ohm resistor here. And all of them, all the current will combine and go back to the main branch. Okay. So we have done all the questions in this worksheet on DC circuit. Homework today, I'll let you know the homework in a short while. Okay. So you may want to copy down the working if you need. Okay, I'll give you 2 minutes. 2 minutes for it. Quickly do it. So you can see for Gary's working, he used very accurate symbol like current of this, current of that. Very, very clear, right? Very good. Actually, for both current electricity, the topic current electricity, and also DC circuit. But I think the questions in this worksheet is not easy. Okay, so homework for today is to finish all the MCQ questions. And you remember a long time ago, I actually give you this question on static electricity as homework. We haven't gone through yet. Long time, I think about 2 or 3 weeks ago. This is your homework for one of the weeks, but we haven't discussed yet. We'll discuss together next week. Okay, so for today's homework is all the MCQ question. Okay, all the MCQ question. There are 20 MCQ questions. Okay, and as I mentioned, for the task, I'll later create a task. I'll just say the second worksheet, MCQ question 1 to question 10. You can take a photo or you can just type out all the MCQ because it's just MCQ, right? MCQ question, you just write down your final answer. It's okay. No step also fine. Or you can take a photo of your work. Okay, so today's homework is MCQ. And please upload your work to the task. Okay, I'll set a deadline there. Okay, so how do you feel the online lesson today? Is it too intense? Some of my students say very intense. How do you feel? Jonathan, maybe you can tell me how you feel. Okay.
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 Yeah.
Okay. Gareth, how do you feel?
Okay.
Okay. Am I too fast or too slow?
Just nice.
Just nice. Okay, thank you. Rachel, any feedback? Can you see everything clearly or you find very intense? Okay, can now. Okay, thank you. Okay,